A developer installs an email tool for their AI coding assistant. The tool works normally. Email go to the correct people. The AI says that the email was sent successfully. Nothing looks suspicious here. But hidden inside the tool is one extra line of code. And that one line silently sends a copy of the email to someone else. And the entire backdoor here was just a hidden BCC. Just one line, that's all it took. This was a real malicious package published on NPM. It pretended to be a legitimate Postmark integration. In this video, I'll show you exactly how the attack worked. And I'll also explain why an AI approval screen might not catch it. And at the end, I'll give you 5 checks you should run before connecting another MCP server. But first, there is one important point we need to make clear. Postmark itself was not hacked. Its API was not breached. And its official code repository was never backdoored. Instead, someone copied a legitimate open source MCP project. They then published an unauthorized NPM package called Postmark-MCP. So this was an impersonation attack. It was not a breach of Postmark. And that difference is very important here. The attacker did not break into a trusted company. They used a company's name to borrow its trust. Alright, before we get into the video, you only need to understand one thing about MCP for this story. An AI assistant cannot send an email by itself. It needs a tool that can connect to an email service. An MCP server gives the AI access to that tool. And then the AI might say, send this message to this person. The MCP server receives this request. It uses an email API key and then it sends the message through the real email provider. So the MCP server over here sits between your AI assistant and the real service. And in this case, the code in the middle was not doing what the user expected. This package was called Postmark-MCP. The name looked real. The description also looked real. And much of the code also looked real. And that is because the code had reportedly been copied from a legitimate open source project. The first 15 version appeared to be clean. They sent email normally. And the crazy part? Those versions were not published slowly over months. They were published quickly, just in 2 days. And then came version 1.0.16. And in that version, a new field appeared inside the email request, a hidden BCC address, and that was the attack. And when the AI asked the tool to send an email, the correct recipient still received it. The tool still reported success. Everything appeared to work normally. But before sending the request, the malicious version also added a second recipient. And because that recipient was added as a BCC, the intended recipient could not see the second address. The email was delivered correctly, but a hidden copy was also sent somewhere else. And the package was reportedly downloaded over 1600 times before it was removed. But a download is not the same as a victim. A download does not prove that someone installed the package. And it does not prove that an email was stolen. There is no confirmed public victim count. There is also no verified public number showing how many emails were copied. What we do know is that the malicious code was designed to secretly BCC email sent through the tool. And those emails could have included receipts, password reset links, login code, customer information, or even internal company messages. They could have contained those things, but as I said, that has not been confirmed publicly. And in this video, we are not trying to present a possibility as a proven fact. Now, let me show you why this attack was so easy to miss. This is a controlled environment. I'm not running the original malicious package here. I'm not using the attacker's real destination address either. And I'm only using test inboxes that I control. Alright, here is what the normal request looks like. The AI receives this instruction, send a password reset email to the user. The tool receives one visible email address. And if your AI client shows an approval screen, everything can look correct. The subject is correct and also the message is correct here. So you approve the action and the email is sent. The user receives the message and the AI also receives a success response. From the user's point of view, everything worked. Now watch what happens when the server secretly adds a BCC address. The user's request does not change. The approval screen may not change. The tool name does not change and the result still says success. But now a second inbox also receives a complete copy. This is the part that is important to understand. The AI did not decide to steal the email. The AI was not shown the change happening inside the package. The AI simply called a tool. The tool performed the action under the user's request, and then it performed one more action that nobody approved. You might think a firewall or a normal network monitoring would catch this immediately, but that may not happen. The malicious package could still send one normal HTTPS request to Postmark's legitimate API. It did not need to make a second connection directly to a server controlled by the attacker. The hidden BCC address was simply another field inside the legitimate email request. So a basic network log could look normal. Your computer normally contacted Postmark, and Postmark just processed an email, and there was no obvious second connection to a suspicious server here. The unexpected recipient might appear inside the email provider's activity log, message records, or recipient data. And that completely changes how you need to defend against this type of attack. Alright, so here are 5 ways to protect yourself. Number 1, verify who published the package. Do not trust a package only because the name looks correct. And never trust the logo either. And do not trust a professional looking README file either. Start from the vendor's official website or starts from its verified GitHub. Then use the installation link provided there. Check who published the package. Check which code repository it links to, and always confirm that the company officially supports it. A package can use a trusted company's name without being published by that company. Number 2, verify the source first and then pin the version. After you confirm that the package is legitimate, pin that exact version you reviewed. Do not allow a sensitive dependency to update automatically without checking what changed. Always review the update first and then install it deliberately. But the order matters here. A pinned package from an impersonator is still a malicious package. First, verify where it came from, then pin the version. Number 3, limit what the server can access. An email MCP server may need an email API key, but it does not need your SSH keys, and it does not need access to your entire home folder either. Use credentials created specifically for that tool, restrict its access to the files, and when possible, run unfamiliar servers inside an isolated environment. Limited permissions might not have stopped this exact BCC attack. The tool was already allowed to send email, but limited permission could stop the same package from stealing unrelated files or credentials. Number 4, always keep approval enabled for sensitive actions. Sending an email creates an external action. So does deleting a file, changing cloud infrastructure, or publishing code, or modifying a production database. Keep an approval enabled for all actions like these or anything that you feel is sensitive in your workflow. But remember what an approval screen can and cannot do. Your approval screen is not a malware scanner. It cannot prove that the code inside your MCP server is safe. It may only show you the action that the client knows about. So approval is useful, but approval alone is not enough. Number 5, always check what the real service processed. Do not only record what the AI requested. Also check what the real service actually processed. For email, review every recipient. That includes your CC field, your BCC field. Create alerts for unfamiliar addresses. Record which package version made the request. Record which API credential was used, and compare the MCP tool logs with the email provider's log. The AI interface might show one recipient, but the email provider might have processed many more. The difference is exactly what you need to detect. And this was not a futuristic AI attack. It was a traditional software supply chain attack placed inside a new AI workflow. The package name looked trustworthy. Most of the code looked legitimate. The tool continued to work. And this is what makes this type of attack dangerous. Malicious software does not always crash. It does not always show a warning, and it does not always stop the application from working. Sometimes it performs the exact action you requested, and then it quietly performs one more. MCP itself is not automatically unsafe, but an MCP server is still a software, and that software can access credentials, files, email systems, or databases. Should be treated like any other powerful dependency. In some cases, it deserves even more attention because an AI agent may call that tool again and again. I turned the 5 checks from this video into a 1-page MCP security checklist. It covers publisher verification, version control, permission, isolation, and provider level logging. The link is in the description below. Use it to review every MCP server you currently have connected, and please do not leave it for later. Do it right now. Check them today. It is much easier to verify a tool before an incident than to investigate everything it accessed afterward. The next story goes one step further. The video was about a fake package. The next video is about 3 vulnerabilities found inside an official MCP reference server for GitHub. Researchers showed how those vulnerabilities could be contained with another MCP server and prompt injection to reach code execution. So checking the publisher is important, but it is not the end of the security process. Sometimes the package is fake and sometimes legitimate software still contains dangerous bugs. So subscribe and I'll see you in the next one. I'm Yudi signing off, the LLM Architect.